Okay, let's start now. So first of all, welcome to this second webinar of the year 2021. So as said on the title, this webinar is going to talk about radiated immunity tests in reverberation chamber. My name is Maxim and I'm going to be your host today, and I work in the BAT-EMC team of Nexio. So just a few rules to start our webinar. There's going to be a presentation moment and then some questions if you have any questions. We stopped all your webcams and microphone is all switched off, and you're going to be able to use the microphone at the end of the presentation to ask any questions if you have. If during the presentation you have any question, do not hesitate to use the chat, and my colleague can answer, or I can answer also if they ask me to at the end of the presentation or during the presentation in the chat. So this webinar is going to be, as I said, 40 minutes long for the presentation part and around 15 minutes for the questions. So a quick overview of what's going to happen during this webinar. First of all, I'm going to present you Nexio. Then we're going to introduce the reverberation chamber, talking a bit about the standards calibration, the MT loaded and EUT calibrations. And then we're going to talk about immunity tests, automatic, manual, and the export and report function of BAT-EMC. So first of all, let's start with Nexio. So Nexio's expertise is electromagnetism, so EMC, lightning, antenna, RF, and stealth. Our activities are the service, so we are a service provider for design tests, and we are RVS for test and simulation. Nexio is about 90 EM specialists, and the turnover on Nexio is 7 million euros. We've got around 250 customers in domains such as aerospace, automotive, space, and the electronic industry area in 25 countries. We also are the world leader in automation test software with a software called BAT-EMC. And we are one of the biggest European engineering company focused on EMC fields. So let's talk about reverberation chamber. So the chamber has been used in an EMC test for more than 20 years. The reverb chamber is an electric large, highly conductive cavity with a mechanism for alternating its mode. When the chamber is excited with RF energy, the resulting multi-mode and electromagnetic environment can be steered by the mechanical Turner's tower. The resulting field is statistically uniform, statistically isotropic, which means that the energy having arrived from all aspect angle, and statistically randomly polarized, which means that with all possible direction of polarization, when average over enough position of the Turner stirrer. Warning, a reverber chamber has a minimum frequency usage, which means that depending on the frequency, you're going to have to make your chamber bigger. So generally, the minimum frequency is between 3 to 5 times the FO, which is the first chamber resonance. So the reverberation advantage and disadvantage. First of all, let's start with the advantages. So the E field direction on each face of the EUT is one of the first advantage. Then immunity on EUT cable in the same test closer to reality, less cost installation because there is no absorbent, and the possibility to generate higher E field. And the ratio field power is really good. Amplifier less expensive or higher field than in an accredited chamber. Disadvantages now. The side of the chamber versus the start frequency, as we said earlier, it all depends on if you want a higher frequency, you're gonna have to have a bigger room. So bigger amplifier with a bigger chamber, obviously. And the calibration, depending on standards, empty and loaded calibration could take time. And the calibration on EUT is highly recommended before starting the test. So let's introduce the reverb standards. So we divided by 3: commercial automotive on one side, aeronautic on the other side, and military to end. So the first standard is commercial and aeronautic, and they're really close on measurement methods and statistic calculation. For automobile specification on reverb are generally close to commercial standards. There was a big evolution in the standard DO 160G to change the method to continuous rotation. The military standard is very different from the other standards, from calibration and test. We will focus on this difference on the next slide. So, sorry, I've got a little issue with my screen. Let me just have a look. Okay, that's good now. So to perform tests in reverberation chamber, the standard asks to perform different steps in advance. For the EIC and DO standards, it requests empty calibration and then loaded calibration. The goal of these two calibrations is to validate the uniformity of the chamber with measurement and statistic calculation. The calibration on EUT will allow to calibrate the chamber with the equipment in the chamber. And at the end, the immunity test is performed on the EUT. You could see that all the steps are needed according to the standards and the version of the standards. So the empty calibration. The goal of the empty calibration is to validate the uniformity of the field in the chamber. So we're going to perform two measurements. First one is the E field measurement. The goal is to make the verification of the uniform field zone. The second one is the power measurement on the received antenna, the measurement of the ratio field power empty. A third measurement is performed to have the forward power and reverse power to calculate the P-net. For commercial standards, the field probe is placed at 8 locations on a perimeter of the chamber working volume. For aeronautic standards, one more location in the center of the volume, so 9 position for the DO 160. On the graphic for commercial, we can see that the received antenna is also present for aeronautic calibration. Standard precise that the received antenna should be placed inside the working volume. No need to go deep in details, but the standard gives more information for the distance with wall, orientation, etc. The number of 8 or 9 positions decrease for higher frequency. This means that above 10 fs, we could measure only 3 positions. So as you can see, the position, there is one in each corner, and you've got the 9th position in the center. So the empty calibration, there's some measurement types. So the value to measure are the E field, X, Y, and Z axis, the received power in the chamber from the received antenna, and the forward power and reverse power, which is optional. These values should be measured for each frequency, for each angular step, and for each position of the field probe antenna. So we can see the SIG gen connected the amplifier, then the coupler in the emission antenna. The power meter to measure the power forward and reversed. The second antenna inside the chamber working volume will measure the power with the spectrum analyzer. The field probe connected to the field meter will be placed location on the perimeter of the chamber working volume, and a stereo to change the reflection conditions. On the computer to monitor and control all the equipment with obviously BAT-EMC. So we're going to talk quickly about the needed mathematic tools just to show you that it's quite simple to use. So there are 3 mathematic tools that we needed. First of all is the function maximum, which everybody knows. Second function is average. Once again, everybody knows it. And the last one is standard deviation, that I guess you know also. So just quickly, the standard deviation, we describe the variation around the average. For example, the average 9 and 11 equals 10. For example, the standard deviation between 9 and 11 is low, but the standard deviation between 0 and 20 is high, because obviously the range of the values are bigger. So for each position of the field probe, we'll measure the field for each angle and each frequency. So we'll perform 2 sweep, angular and frequency. The frequency is faster to change than the angle, so we perform a frequency sweep for each angle. And then at the end of measurement, we'll have a table, frequency angle. Standard asks to find the maximum for the field x, y, z, and one complete rotation for each frequency. This value is normalized, divided by the square root of the input power. When we have performed 8 or 9 positions on the field, we could calculate the average. So we'll now calculate the variation of these maximum values based on the average. This is the standard deviation. We use the formula defined in standards to calculate the standard deviation for each probe axis and in dB. The standard deviation in dB should be below a limit defined in standard to confirm the uniformity of the volume. Warning, on the 1.06 coefficient, the coefficient is written only in DO160 standards, not in the IEC. BAT-EMC will allow you to calculate according to both formula, with or without. In the same way, we measure the E field. We also measure the received power in the chamber. We'll measure all power according to the frequency, angle, and position of the antenna. We will have the same table as previously, with two sweeps, frequency sweep and angular sweep. We will calculate the average on one complete rotation of this receiver power. This value will be normalized by the forward power. This value will be used to calculate the quality factor, the time constant, and the power the power to generate for the test. But this value has different name according to different standards. We're going to see it in the next slide. So as we just said, there are different names depending on the standards and the revision. For example, for the 6100421, it's called antenna validation factor, AVF. But for the DO160F, it's called ACF-MT, it's antenna calibration factor. But for the same standard but with a different revision, for the G, it's CCF, chamber calibration factor. So we add a warning because in a DO160G, the CCF is the average power of the MT calibration, as written above. But in version F, the CCF is the average power for the calibration on UT. So it's important to properly read the standards and the revisions to know exactly what it's called. So BAT-EMC will allow you to define the information from the standard: chamber volume, the antenna efficiency factors for the transmit and received antenna, used for quality factor and time constant, and the homogeneity limit. So the configuration in BAT-EMC now. We can go quickly on traditional parameters such as start and stop frequency, frequency step, and equipment setup. Same as immunity test, but in anechoic chamber. We can start on regulation type. There are two possibilities: generator command or regulation on forward power. The generator command is recommended because it will be faster. All measurement will be normalized by forward power, so no need to regulate. We could find the number of positions for the field probe and antenna 9 or lower. Calculation method for the received power in a chamber with maximum value or average and normalized on forward power or net power. There's also the number of steps for the turner and the 1.06 coefficient according to the standard EEC or DO160. At the beginning of the calibration, you could choose which sub-range you want to perform and which position for the probe and for the antenna. After this, you could choose your equipment setup, same as the other type of test in BAT-EMC. Hold on, I've got a problem once again with my laptop. Okay, so we just saw this slide. All right. So before the measurement, we're going to have to choose the equipment and the equipment setup. And during the execution, we display the measured value of E field and power, maximum on one complete rotation. We display the statistic calculation such as standard deviation, quality factor, time constant. On these two examples of graphic, we would see the maximum E field on one complete rotation for the different position. This is a cloud of curve around the average. On the second graphic, the standard deviation and the limit of 3 dB. So we've got an export function. So in this export file function, you can find all the measurements, so E field, powers, and forward and reverse power, and for all frequencies, all angular step, and all positions. There's also a statistic calculation table, which is available with all the calculated values. So now the loaded calibration. The loaded calibration makes it possible to know whether the isotropic or homogeneity properties are still respected when the chamber is artificially loaded around 12 dB. A loaded calibration is required for the EIC 6100 and DO160F and earlier standards. Calibration under load is not necessary for the DO160G and Miller standards. The goal is not to load the chamber exactly at 12 dB. This value will change with the frequency and positions, but the goal is to load enough currency to the equipment load will be lower, and then the E field will be uniformed in the volume. So the measurement method is exactly the same as the MT calibration, with two measurements, E field and power. And the results are similar as the MT calibration with one more calculation, the ratio of power called loading. In the configuration of BAT-EMC, we'll select the MT calibration to use the received power from the MT calibration. BAT-EMC checks the parameters between both calibrations, number of positions, angle step, etc. BAT-EMC will use the MT calibration information to calculate the loading factor. So calibration with equipment measure the power ratio or field ratio with the EUT in the chamber. This measurement will allow to calculate the power required for the test. So for IEC and DO160F, there is no field measurement and the measurement of the receiver power. Same calculation method as MT and loaded calibration. Then the CLF will be used to calculate the required power. For the DO160G, we do a continuous or step-by-step rotation method, the calculation of the Emax from the maximum power received over complete rotation, and the forward power measurement, it's max forward power over complete rotation. Then these two values will be used to calculate the record power. The Mill STD offers two methods of calibration, of calibrating the chamber with the equipment. The field or power method. For the two methods, it's necessary to calculate a calibration factor which will be used for the calculation of the record power. BAT-EMC allows you to use both methods. Here is the calibration configuration window with the power methods according to the EIC, DO160F, DO160G, and Mill STD. We add the MT calibration and the loaded calibration as a comparison parameter. BAT-EMC checks that the MT and loaded calibration are the same. BAT-EMC will allow you allows you to possibilities for the styler in turning and steering mode, step-by-step or continuous rotation. Here is the calibration configuration window with the field method, only used for Mill STD. So for the configuration in BAT-EMC, you can select the steerer, so step-by-step or continuous, and there are two types of sweep, frequency or angular. According to the standard and the formula you want to use, BAT-EMC gives you the possibility to choose the regulation you want. So depending on the standards, there are a few calculations that you can pick in the regulation combo box in BAT-EMC. Performing a CRBM test is very similar to a classic anechoic chamber humidity test. BAT-EMC regulates the incident power to obtain the power calculated by the formulas given previously. The only difference is a dual frequency and angular swap. So the manual mode. In manual mode, the operator can modify parameters such as frequency, modulation, the angle, and the generator level. It's possible to use control tools also to monitor the EUT. Then to finish, so as we do for all testing BAT-EMC, you've got the ability to export results to Excel and to generate an highly configurable test report. For the one who knows BAT-EMC, we can generate a report with your own tags, your own font, your own graphic, etc. Everything can be configured before. So it's the end of our presentation. If you have any questions or if you ask any questions, I'll let my colleagues answer to them. Thank you. To be able to ask questions, you might need to activate your audio, your microphone. Or if anybody in the team wants to take the lead.
Hello, hello everyone. Hello Maxime. So thank you for your presentation. Can you go back on your slide with the equipment setup? So we have a question related to this one.
All right, let me just go back to it. This one, it was this one?
Yes, so we have one question to ask us if we could show this one again. So just we can talk a few minutes on this one. So this equipment setup is really close to what you have in a traditional immunity test. So you could find signal generation with the SIGGEN amplifier to the transmit antenna, and you have the forward power, and after you have the specific line dedicated to the reverb, the E-field measurement, the received power in the chamber, and you have also the stirrer. So I hope I answer your question. If you have a question about the equipment setup, we have one more question.
You could able to hear me? Yeah.
Yes.
Where is this stirrer located in this equipment chain? That is the last one with yellow color. What we see, that is the stirrer, right?
Yes, in annex. So we have the stirrer in annex. So obviously we need to manage the stirrer.
And this receive power, you have put a E-field probe. Is it also possible that and it can be configured as an antenna?
Yes. You want to measure the
antenna?
The field probe. You want to measure with an antenna?
Instead of yes.
No, I think you can't, because you need to use the field probe because you need to have X, Y, Z component. So I don't think, no, I don't see any way that you could use an antenna instead of the field probe. The field probe is clearly needed because you need to measure X, Y, Z.
Okay, okay, understood. Yeah, okay.
So I have, do I answer all your question?
Yes, there was another question which I have put on the chat. Can you little bit explain us how you control this stirrer when we do this angular mode and the other frequency mode, how when we do in the continuous mode, how you control this stirrer? Can you little bit elaborate there?
Okay, so I could explain you. So in continuous mode, so we will in a certain way we'll do a test in reverb really close to an traditional test in an anechoic chamber. The only difference is we'll need to wait the dwell time as the same as the time for a complete rotation. So at the beginning of the test, we'll activate the rotation of the stirrer with the speed, and after we'll go frequency by frequency, and at each frequency, when we reach the target, we will wait for one complete rotation. So we'll wait 15 or 10 seconds at each frequency.
So you mean to say at each frequency you make a field leveling, then you rotate the stirrer one complete rotation, correct?
So the stirrer is rotating in continuous, so it's always moving, and we leveling, as you mentioned. So we do leveling, and when we reach the target, we are waiting one complete rotation to be sure that the equipment received all the different possible field from the different
Understood.
positions.
And during this course, we could also able to read the field, correct?
We could read the field. After the field will be just for information, so it will be just just for information, because we do not regulate on the field.
Understood.
Okay.
Understood. Okay. Yep.
Okay. Thank you. So if you do not have more questions, I will go back to the question we have. Can a calibration with 24 zero step be used to generate a calibration with 12 step with existing data to save measurement time on increment range instead of this number of step measurement? So it's so now it's something that we could not do. After it's our customer do not ask us to develop such function, so this is why we have not developed it. After, yes, it could be a good idea to save time, just to avoid to repeat the empty calibration. After, the empty calibration normally is only made once, so this is why we probably we have not developed yet. So if you are interested in our solution, so it's something that we could do because we have all measurement, so it's just a calculation. So after, do you have any records that BAT-EMC have used for vibrating inside reverb? Sorry, I do not understand this question. Do you have any records that BAT-EMC have been used for vibrating? No, I do not have any information about vibrating reverb test. So no, sorry, I have no information about this. Vibrating. So again, so what do you call vibrating? So we have two questions about vibrating reverb chamber.
Since we do not see the question, only we cannot answer. We cannot reconfirm. Can you know who has raised that question?
Sorry, I think you could see all questions. So we have these two questions from Marty and one more question from Daniel. But apparently, is a method with shielded tent but not solid. Make me shake the tent instead of rotating the stirrer. So yes, and I just have a discussion with a company who made a reverb tent. So last week, they told me that they want to use a stirrer. So no, I do not have any feedback on this type of vibrating chamber. After what I think is so obviously we could do something, but we need to have I don't know how you will move this chamber, how you will move the tent. If there is a mechanism to move the tent, yes, we could communicate with this controller to move the tent, and I think in this way it will be more similar to a continuous rotation than a steering position. So after, I do not have any experience on this, so it's something that we could we could talk. If you are, I don't know how to ensure that the movement you would give to this tent could be reproduced during the test. So for me, the more question would be how to ensure that the movement of the tent could be reproduced between the calibration and the test. So we can talk about this later. And yeah, I do not have any experience on this. Yes, we will share the presentation. So we have a lot of information in this slide and comparison with standard. So yes, we'll share the video and also the PowerPoint. So you're welcome for people who say thank you. Can the field probe and antenna value be sampled during continuous rotation? Can the number of sample per rotation be set with BAT-EMC? No. So during the calibration, you will use the step-by-step position. So it will be in tuning mode, not in steering. So we do not have, we cannot sample the probe and the antenna. So it will be only in step-by-step where we could check field probe and antenna. When you use the continuous rotation, the D160 allow only for the calibration on EUT. And in this case, what we would recommend, because we need to have the maximum on one complete rotation. So in this case, we'd recommend to put the spectral analyzer on span 0 and max salt. And in this case, at the end, we'll measure directly the maximum. So it's the best way to measure the maximum on one complete rotation, continuous. With one dongle, I have one more question. With one dongle, existing test method, reverb can be added. So if we talk about license, so we have one license for radiated immunity test in an anechoic chamber, and we have one license for reverb test on a reverb chamber. So we have two different license for radiated immunity, one for anechoic, one for reverb. And so yes, to answer your question, yes, we could put both license on the same dongle, but due to you will have two different chamber, I will recommend you to have two different dongle. It will be easier. So, do you have more question? So feel free to activate your micro if you want to ask a question. We will be pleased to answer you. So you could use the chat or question, or you could use the micro as you want.
Only the last question from my side. The easy monitoring part remains the same, right? There is no change here. We can use the same existing easy monitoring even in this method.
Yes, exactly. So at the end, we just write in a few in the latest slide that we can use the monitoring. So all the monitoring we have in traditional immunity test conducted radiated with easy control, multimeter, oscilloscope, data logger, camera, CAN bus. All of these options we have for monitoring are obviously available also for reverb testing.
Yep, thanks.
You're welcome. So no more question.
Oliver, I have
yes.
one question.
Yes.
So how is this reverb emission different from Alce emission measurement?
Sorry, can you repeat?
Do you have any standard for reverb emission method?
For emission, sorry. So in emission, in reverb, the standard have mentioned some calculation and some measurement algorithm. So we have implemented this algorithm also in BAT-EMC. So first, we want to present both immunity and emission in this presentation, but after we realized that it will be too long in one webinar, so we decided to focus on immunity only. But yes, some standard explain some method for emission, and this method use the some of the statistic calculation we made during the empty calibration. So we need to perform the empty calibration also for the emission measurement, and after the there is an algorithm and some measurement for this part.
Okay.
So thank you for all of you for to participate to this webinar. So I hope you enjoy. I hope you learn. You had some information from a reverb test. So